Alright guys, welcome to Subu Medicines, and today we'll be discussing about the posterior pituitary, okay? So if you see this structure right here, okay, this is your central nervous system right here. This is going to be midbrain, pons and medulla, and your spinal cord, right? And this is going to be cerebellum right here. So if you see, look at this structure, this is what it will be focusing right here. This is going to be right here, posterior pituitary, and this is going to be anterior pituitary, and this is going to be your infundibular stalk, and this is where you're going to be your hypothalamus, right? So if I just like zoom in, and if I draw the structure, this is what's going to look like, okay? So this is going to be a hypothalamus right here. This is going to be central nervous system down up there. And then the different nucleus, we'll talk about this, okay? And this is going to be my posterior pituitary right here. This is going to be my anterior pituitary, okay? So now, so let's just write down. This is called adeno, okay? You guys know this, right? Adeno hypophysis, right? This is what it's called right here. This is not what we'll be focusing. We'll be focusing on today here on this posterior pituitary. Just letting you guys know this, the posterior pituitary, or also another name for this posterior pituitary is what? It's called neurohypophysis, okay? The reason why we call this is because it's neuro, because it is an extension of your central nervous system. It's a derivative of neural tube, okay? This is extensions of hypothalamus, okay? Or it is a derivative of diencephalon, okay? That's the reason why we call this posterior pituitary as a neurohypophysis, or you can also call this as a neural lobe, okay? This is something that you have to remember. Or always posterior, it's going to be posterior pituitary, okay? That's what it's called. Now, remember this, that, what we need to know is that the posterior pituitary is very, very important. The reason why it's very important is because they're going to store some very, very important hormones, okay? One of the most important things that's stored here is that, I'll write it down here, okay? One is called arginine vasopressin, or another name is called ADH, which is antidiuretic hormones, okay? So these guys have here ADH, also oxytocin. You want to remember that. Same thing, ADH, oxytocins, ADH, oxytocins, ADH, oxytocins, ADH, oxytocin, all that, okay? So that's going to be down here in your posterior pituitary, okay? Now, one more thing that we always have to talk about is the way, okay, the synthesis of this ADH and oxytocins, okay, that actually takes place in a hypothalamus, because this hypothalamus is the one that contains the cell bodies, okay? They have the gene to produce this ADH and oxytocins, okay? So basic synthesis of this ADH and oxytocin that takes place in the hypothalamus, but the storage of this ADH and oxytocin that takes place in the posterior pituitary, okay? So remember, just letting you know, the synthesis, okay, of the ADH and oxytocin that does not take a place in your posterior pituitary or your neurohypophysis, okay? It takes place in the hypothalamus. Just remember that. And the way, when the synthesis happens, the way it gets to down here is that through this neuronal axon tract, okay? These are non-myelinated bundles of actions. Okay, let's just make this, okay? And the same thing here. There's a bundles of actions, okay? There's bundles of tracts, which are actions, okay? That's how these guys come here, okay? Now, one more thing that we also have to talk about here is that, there are other cells are located here too, okay? Because remember, there's a blood vessels also coming down here, which are called, what do we call this? This is called your inferior, okay? And then your hypophyseal artery, okay? So it's an inferior hypophyseal artery which breaks down here and give the fenestrated capillaries down here, okay? And from there, later it goes to the systemic circulations. Now, I know there are different types of endothelial cells here, okay? Like there are fibroblasts and mast cells. But always remember one cells that are very, very specific to the posterior pituitary, okay? And it has a similar resemblance as astrocytes, okay? But those cells are called, okay? Let's just make this some of the cells, okay? Down here. Let's just make this like some of the cells right here, okay? These cells are called pituocytes, okay? These are called pituocytes. These cells are called pituocytes, and these are specifically, okay, specific towards your posterior gland, okay, or your neurohypophysis. Now, okay, now let's talk about how does the synthesis takes place in this different types of nuclei. Okay, you should remember always this, there is a specific nuclei with this one right here. I'll name this as a, let's say, supraoptic nucleus, okay? And this is very, very important for secreting or synthesizing your ADH or your arginine vasopressin, okay? And this is going to be your paraventricular nuclei, okay? And this paraventricular nuclei is especially important for synthesizing your oxytocin and a little bit of your ADH or your arginine vasopressin, okay? It's a different name and nomenclature given for the ADH, okay? Now, so the way it works is that let's say the way this, because these are nuclei, right? Or we also call the cell body because they have a specific gene that actually is important for synthesizing these different types of hormones, okay? So this supraoptic nucleus, okay, at the chromosome number 20, okay, they have a specific gene to synthesize your arginine vasopressin, okay? That's very important. So what happens is that, okay, let's just write it down here. So whenever the way at the chromosome number 20, they will, first what happens is that they will specifically start, like, you know, synthesizing vasopressin gene, okay? What's going to happen? First, the transcription will happen, right? From the transcription, what is going to happen? After the transcriptions of the gene, okay, it's going to read by the ribosomes, and I'm not going to go super detailed about that, but remember, what they will synthesize is that ultimately they are synthesizing peptides, right? So they will synthesize so-called your pre-pro, okay? Because it's a vasopressin we're secreting. They call this a pre-pro, it's called vasopressin. Okay, that's what it is. They'll secrete this is called pre-pro vasopressin, okay? And then what is going to happen? This pre-pro vasopressins, it will be taken by, let's just make this as in the rough, let's say this is a rough endoplasmic reticulum right here. This pre-pro will be taken by this in the rough endoplasmic reticulums, right? And in the rough endoplasmic reticulums right here, let's just write rough, and it will go the further modification where this pre will be out and they will have just a pro, okay, vasopressin, okay? That's what it's going to have. And then there's a further modifications happen, cleavage will happen, okay? And then end result is that they will kind of get bought off and go to the Golgi, right? They will go to this Golgi. Let's say this make it as a Golgi right here, okay? And even there too, if they need to even further modified, that will take place in here, right? So now, this pro vasopressin, when it comes out from the Golgi, it comes out in a couple of forms, okay? If I'm talking about this neurophysin gene, first of all, okay, you will come out as an arginine vasopressin, okay? And then other one is what? Other one, it will come out as, okay, you have to remember this, so-called your copeptin, and then other one is called neurophysin number 2, okay? This is what it is. So these three of them, okay, is after the cleavage process, okay, you're gonna see in a Golgi, you're gonna see arginine vasopressin, copeptin, and neurophysin, okay? So these are just a breakdown. During the proteolysis happens, okay, during the cleavage process, which is taking place in rough endoplasmic reticulums or Golgi, okay, in the post-translation, these are the three, okay, the peptide hormone that is gonna get synthesized. And the reason is very important that whenever this gets secretes from here, right here, okay, the arginine vasopressin, copeptin, and neurophysin, they'll come and go and then can it stored in these different types of granules which are present in posterior pituitary, okay. These granules are called neurosector granules, okay, which has the cell bodies and they contain all these types of peptide, okay. And we call this specific name is given for this neurosector granules, we call them herring bodies. Okay, it's called herring bodies. So from basically the supraoptic nucleus are synthesizing arginine vasopressin, copeptin, and neurophysin too. Okay, and this is why it gets stored in this neurosector granules. Okay, through this action, non-minor action, they come and they store at the posterior pituitary. Remember, this copeptin is very, very important because what happens? This arginine vasopressins or ADH. What happens is that when they go to the circulations, their half-life is not stable, okay? But this copeptin half-life is stable. So because of that, we use this copeptin as a clinical, okay, it's a biomarker, okay? To evaluate the functions of renal, functions of the cardiovascular system. Because it is more stable, we can able to determine how much arginine vasopressin is releasing to the circulations, okay? That's the reason why this copeptin is very, very important, okay? And with that, this protein, this neurophysin also come along with this, okay? Now, after this, okay, same thing that happens with this, your oxytocins also, okay? The oxytocins also, really, because we're talking about this, in the paraventricular nucleus, okay, they have the gene for this oxytocins. So they are gonna make, okay, transcribe pre-pro, like oxyphysin, you can simply say this, okay? And then in the rough endoplasmic reticulums and Golgi, they'll get a post-translations process, and ultimate result is that they will make, okay, you're gonna have a oxytocin, okay, end product, and other one is gonna be a neuro, okay, physin number 1, all right? Because this is neurophysin number 2, and also like some glycoproteins, okay? That is very important. So these 3 things, okay, that gets synthesized from the paraventricular nucleus, and then from these actions come down and is stored in the this herring bodies, okay? That's what it does. Now, after this, we have to talk about a little bit of like, what are the factors that can stimulate, let's say, this ADH? And we'll be just focusing on the ADH right now. I just want to quickly touch on the oxytocins, but I'll talk about the function of the oxytocins in a different lecture video, okay? Now, the way it works is that if you see down here, okay, look, if you guys remember, there's like what? There's something called your corpus callosum, right? And down here, there's a pharynx too, right? Down there is pharynx. Basically, in the pharynx, below the pharynx, there's a special, this organ here, we call him as a subpharyngeal organ, okay? And then, also down here, okay, they're kind of connected at the, near the lamina terminalis, okay, around like a third ventricle, okay, there is a special name that is next to there is given there is something called laminal terminalis, okay, organum vasculosum, okay. This is called lamina terminalis organum vasculosum, okay. And in between this space, okay, there is a special nuclei right here, which is called MN, okay, which is a median preoptic nucleus. Preoptic nucleus, okay. Now, what really happens is around there, the blood-brain barrier is actually broken down here, okay? Blood-brain barrier, and there's a lot of cells down here, okay? And these cells are called osmoreceptors. The importance of these osmoreceptors is that these are very, very sensitive to the, okay, osmolarity, okay? Because there's a blood-brain barriers, okay? And then these cells can detect the osmolarity, and that they can give us certain signals to this median preoptic nucleus, and this median preoptic nucleus can actually stimulate this nucleus, which is a supraoptic or paraventricular nucleus, especially supraoptic nucleus, to actually, secrete or not to secrete this hormone, which is a origin in vasopressin, okay? Remember this word vasopressin, quickly want to emphasize. This vasopressin, the reason why they call this vasopressin is because if there's a higher concentration of ADH released, okay, it works in the smooth muscles and it does the vasoconstrictions, okay? That's not why they call this as a vasopressin gene. It's called vasopressin, okay? Now, what are the factors that actually can stimulate, okay, the release of this supraoptic nucleus? That's what we talk about, right? So let's write it down here. What are some of the factors, okay? One thing is that factors is that hyperosmolarity. Basically means that let's say what are the factors that can cause hyperosmolarity? Which basically before even we go there, what is the osmolarity of your blood? Like osmolarity of your blood, of our extracellular volume, right? The osmolarity is around about 290 milliosmoles, right? It varies from person to person, but that's around that, okay? So whenever there is osmolarity, let's say when it goes more than 300, let's say varies to varies, when the osmolarity is going on, when it becomes hyperosmolarity, what happens is that these cells down here, okay, these cells, these osmoreceptor, this will, what happens, start losing the water, okay? And this cell starts shrinking, okay? And they're going to detect there has been what is going to happen is the tonicity of the fluid has increased, okay? It becomes hyperosmolar, right? So what the ADH does is that it can give signals to this median preoptic nucleus, and that can actually send the signals to this let's say, supraouter nucleus to secrete oxygen and vasopressin. And so far, we haven't talked about the functions of oxygen and vasopressin. Remember, and we'll talk about it. But just now, just note that it will this osmoreceptor will detect it and then give us signals to this, and this medium preoptic will give us signals to these guys to synthesize more, let's say, your ADH hormone, okay? So, let's say one cause, as we discussed, it is going to be hyperosmolarity, okay? Hyperosmolarity. All right? And what else? Remember, okay, now let's talk about functions of the ADH. One of the main functions of the ADH is what? One of the main functions of the ADH is to retain water, to maintain the osmolarity of your extracellular volume, okay? And mainly it reabsorbs water from your kidney tubules right here, okay? It is very, very important. If, let's say, if there's no ADH, then do you know this? That you will be excreting out like about 24 liters of water like in a day. 24 liters of water. That's a lot of water, okay? So basically without ADH, you would be dead. That's what I'm trying to say here, okay? So it's really important that ADH, what it does is that it reabsorbs the water, okay? That's one of the main functions of ADH. It maintains the osmolarity.